Hi, welcome to a quick tour of some selected problems from our two-dimensional motion problem set. We're looking at some horizontal launch problems here. It's a chance to where we're using our motion equations for both x and y motion. That means we're going to have motion equations going on for x variables and for y variables. And big thing, we're going to have to keep those separate. Um, so I'll show you what we're talking about here. This problem here, it often causes a lot of questions. Students get a little bit confused about it, but it's a really good one to work with. So number 2, it says a ball is launched horizontally from the top of a cliff with an initial velocity of 20 meters per second. The trajectory of the ball is shown at the right. Express your understanding by filling in the blanks. Now, when we don't know what else to do, when we're feeling a little overwhelmed, we like our GUESS acronym of givens, unknown, equation, and stuff, but when you really don't know what to do, start by very carefully defining what is the unknown. Were we being asked to find? So look at the blanks here. I want the y velocity after 1 second. I want the x velocity after 1 second. I want the y velocity after 2 seconds, and then after 3 seconds and 4 seconds, and same for the x velocities. These are velocities after. So we are being asked to find the v final for y and the v final for x. And that's okay. That's okay that we have two unknowns because we're going to need separate calculations for them anyway. So I need to get all of the givens I can for x, all of the givens we can for y, and see what we can do with them. So I'm going to make an xy table. Some people on their xy table like to list their motion variables right down here down the side, and they fill that in. That's one good way to do it. Another good way to do it is I don't do the table so much, I often just write my givens. So for example, it said the initial velocity was 20 meters per second. And so they show us here, it's pretty clear that that velocity is entirely in the x direction, 20 meters per second, horizontal. V original x is 20, because if it was launched horizontally, it wasn't moving up or down at all. Well, note then that that doesn't mean we don't know the y velocity. We know that the y velocity, if it wasn't moving up or down in the beginning, the initial y velocity is 0. Oh, hey, there's two very useful givens. Second, anytime we have an object in free fall, anytime it's a trajectory, a projectile, there's only the force of gravity. That means we know automatically that there is a y acceleration of about 10 meters per second squared down. So I'm listing that as about negative 10 meters per second squared. I also know that my x acceleration is 0. Now, this wasn't given to us in the problem. We have to know that about any free fall motion, that gravity pulls down and causes an acceleration of 10 downward and causes no sideways acceleration because gravity doesn't go sideways. All right. Finally, the way this is set up, they ask us to figure out what the final y velocity and final x velocity is after 1 second. So I'm going to set this up to solve for 1 second. But then we can see here that it's going to be 2 seconds and then 3 seconds. So after I do the setup for 1 second, I'll just change that out. I'll change that number out and just repeat that same process. So on the one hand, that can be a little bit confusing. On the other, if I already have time, that's really nice because that's a given for both x and y. Okay, so you can see here we have 3 givens for both x and y. So I can figure out what my v final x is. I can figure out what my v final y. Let's start with the v final x's. The equation that matches my v original, a, t, and v final is v final equals v original plus a, t. Then I'll go in and label these with the x's because that's what we're talking about. And if I want to solve for my v final x, cool, already got it alone. And I'm going to zero this part out because the x acceleration is 0. So, oh, the v final x equals the v original x. Hey, really? Yeah, that's all there is for the x velocity. The final x velocity is constant when we have a projectile. So whatever initial x velocity it has, After 1 second, it's 20 meters per second. And I can change out my givens, 2 seconds, 3 seconds. It's still going to be v final x equals v original x. 20 meters per second, 20 meters per second, 20 meters per second. And the last one, yeah, 20 meters per second. Okay, now let's figure out our v final y. If I look, v final, v original, a, and t, it is the same motion equation. That's not always going to be the case, but here, my givens and my unknown led me to the same equation off the equation sheet. V final equals v original plus at. In this case, though, we actually have an acceleration, and it's the v original that was zeroed out. So, for 1 second, my v final y, after 1 second, negative 10 meters per second squared times 1 second equals negative 10 meters per second. 10 meters per second down, in other words. My v final y after 2 seconds. And once you've set it up once, we're not going to ask you to show every last piece of work, but I'm just being totally clear about what I'm doing here. Negative 10 times 2, negative 20 meters per second. Because that's what our acceleration does. It adds on 10 meters per second. So we go from 0 to 10, 10 to 20 in the negative direction, 20 to 30 in the negative direction, from 30 to 40, and there's our v finals. Okay, now I need to add one other piece because sometimes we'll just ask what the v final x and v final y is, but sometimes we'll ask you for a v final that is, what is the combination? I mean, we can say, oh yeah, it's moving 20 meters per second sideways and 40 meters per second down. Yes, but how fast is that? Because it's faster than 20 and it's faster than 40. So the way that we figure that out, if I want to figure out my total v final, not just the y or the x, but the combined v final, is I draw a triangle. That triangle has 20 meters per second to the right and 40 meters per second downward. And what we call the resultant, the combined vector here of both the x and the y, ends up being a squared plus b squared equals c squared. So 20 squared plus 40 squared. And I put that into a calculator. And I get about 44.7 meters per second. Okay, so moving on to our next problem. I chose problem 4. And this was a good example of a different unknown, different setup. It didn't have all the x and y already split out for us. So for number 4, it says we have this steel ball that rolls with a constant velocity across a tabletop. They give us the height of the tabletop. It rolls off and hits the ground 0.352 meters away from the edge of the table. So I'm going to sketch this real quick. And I recommend doing that for yourself on most of these problems. So it goes rolling off the table and falls down. And so it said the top of the table was 0.950 meters. And it said that the ball hit from the bottom of the table 0.352 meters along the ground. Okay, how fast was the ball rolling when it left the table? So what was my velocity right here? So first off, what was the key unknown? As far as the trajectory goes, is this at the beginning of the flight or the end of the flight? It's at the beginning. What we want is the v original. Now, what we should be asking then is, well, is it v original x, v original y, or is it a combination? Well, it said the table was horizontal and it rolled off the edge here. When it first rolled off the edge, was it moving up or down at all? No. And that's a fact that we want to always be aware of. At the top of a trajectory, when we have this half a parabola, or in any regular parabola, the y velocity at the top is going to be 0. So if there's any motion, it's because the ball is moving sideways. So I need to recognize that when I want the v original, what we really want is v original x. Okay, so I'm going to set up my table with my x and my y givens. I'm going to mark that v original x is my key unknown. V original y, I'm going to write that down as 0. I'm going to look at my givens. 0.950 meters high. That's vertical. That's the y. The y displacement. The ball fell 0.950 meters. So that's why I'm putting the negative on there. The ball fell. It had a downward displacement. We know that while it fell, it had an acceleration of about 10 meters per second squared, downward. Over on my x side, just like we know that we had 10 meters per second squared acceleration for y, we know that the x acceleration had to be 0, because after it left that table, nothing was touching it. The only force on it was gravity. All accelerations are caused by forces. Well, gravity only goes up and down, so no x acceleration at all. We also know that the x displacement was 0.352 when it hit the ground. So 0.352 meters. Okay, now v original x is my unknown, and I only have 2 x givens. All right, so this leads us to a problem we often encounter. I want to solve something. I don't have enough givens on my x side. I don't have enough givens that directly go into this equation. I need to go get another given. Well, there is one variable that does for both x and y. That, in other words, one variable that we could solve for on the y side. That's time. So if you don't know what else to do, solving for time is always a good idea on whichever side you have 3 givens on. So notice we have all the givens we need to solve a problem on the y side, but it's the x side that we have an unknown. Side quest. We'll figure out the time, and we'll bring it over to the x side. So watch. I go displacement, velocity, acceleration, time. Which one of my equations has those 4 in it? When I look at my equation sheet, it's displacement equals v original t plus at squared over 2. Then I take care to note that these are all y, because I can only use, to calculate with y stuff, I can only use y stuff. We cannot mix and match our givens. So I'm going to only use y variables in this equation. V original for my y was 0. So, okay, my distance in the y direction equals at squared over 2. If I solve to get my time alone, I have to multiply by both sides by 2. So that's 2 times my y distance. Divide both sides by a, okay? So 2d over a. And then, because this was t squared, and this is only when I solve for t squared that I have to do this, that I have the square root. I only need to use the square root to solve for an unknown that in the original equation is squared. Okay, so I solved that. I put in time 2 times my negative 0.95 divided by my negative 10. My negatives cancel out there, because having negatives under a square root sign, that's not a good day in physics. We don't like imaginary numbers. So, all right, square root. I'll use my calculator, and I get about 0.436 seconds. Now, please note, that is not the key unknown. That is not the end of the problem. But this guy, time equals 0.436, now gives me a complete set to solve for the main unknown that I wanted. So I have displacement, velocity original, acceleration, and time. The equation that matches all of those ends up being v original t plus at squared over 2. Okay, now I'm going to admit something here. As far as our x motion goes, because the x acceleration is always 0, we always end up doing displacement equals velocity times time because x motion is always constant velocity. So it's always smart to set up our givens and check our equation sheet, our 4 motion equations, but when it comes to the x motion, we're going to be coming back to this guy again and again and again. All right, so to solve for my original x velocity, I need to divide both sides by time. So displacement divided by time. And so I plug in my numbers, 0.352 meters divided by my time of 0.436 seconds. And when I solve that, I get about 0.807 meters per second, or 80 centimeters per second. That's a slow walk. All right, let's move on to the last problem. Number 8 is quite a bit different than the other problems that we've had, but we're still going to end up using the same core principles. Separate our givens, have our x and our y, use our motion equations, and be patient. So it says a skier leaves the horizontal end of a ramp with a velocity of 25 meters per second, lands 70 meters away from the base of the ramp. How high is the end of the ramp from the ground? So same basic setup. But 70 meters, not drawn to scale probably, leaves the ramp with a velocity of 25 meters per second. Okay, so how high is the ramp? Identify that unknown. It's a displacement. It's in the y direction. We want the y displacement. So I'll set up my table. dy is my key unknown. Let's see what else we can figure out. Well, we know that the y acceleration is 10 meters per second squared down. We know that we had an x displacement of 70 meters. And here we go with our velocity again, 25 meters per second at the top, at the beginning. So this is an original velocity. And not only is it an original velocity, we can be sure that this is an original x velocity. Because if the surface was horizontal, then the skier, when they left, even though they were going 25 meters per second, none of that was up or down. So their initial y velocity was 0. Okay, so that's a given that we often forget, and that's going to be a key thing for us. Oh, it looks like we're pretty much on a roll. Over on the x side, we should also remember that our x acceleration is 0. Okay, here's that setup again. I have one unknown, 2 givens. I need something else. That something else that we can get from somewhere is time. If I just had time, then I'd have a whole set of givens here to work with. So I'm going to go over here to my x givens, solve for the time, and use that. Okay, well, with that in mind, displacement, velocity, original acceleration, and time. Since my x acceleration is 0, x distance equals x velocity times time. Solve for the time by dividing both sides by that x velocity. And so when we do that, we get 70 meters divided by 25 meters per second. And I get that my time is 2.8 seconds. Long time in the air. So 2.8 seconds. Okay, now I have that last given that we needed, and I can solve for my dy. We end up using the same motion equation. Again, that's not the way it's always going to work, but because acceleration and displacement and original velocity, because we have that information, this equation is going to get a lot of work out whenever we have these trajectory problems. All right, so we know that the original y velocity is 0. So to calculate the y, it just ends up being acceleration times time squared over 2. So negative 10 times my time, 2.8 seconds squared, divided by 2. And if I put that in the calculator, I am going to get a negative number because we had a downward motion, and I get negative 39.2. So negative 39.2 meters, or 39.2 meters, the skier went down. That's it. I hope this helped illuminate some problems for you, and hope these get to be pretty routine and easy for you to work out. Happy physicsing!